our previous video, we saw stuff as hash join, in which we saw how hash table is created from joining key and criteria on which Spark decide which data frame to keep in RAM. We also saw the difference of the time complexity for the same. In addition, we also did a practical where we force Spark to perform hash join for us and validate it using Spark plan. In continuation to that, next video. Till our YouTube, well, welcome back to another video. So in this video, we are going to discuss about the broadcast join. And in broadcast join, before we deep dive into it, we need to understand few basic terminologies, and let's go deeper and start it. Okay. So what happens is whenever we do a broadcast join, right? Let's say I have my executor. Okay, this is my executor because the work belongs to executor itself, executor and the worker node. Okay, EXECUTOR. Okay, this is my executor, and I will copy the same thing, Control C, Control V, and this is my second executor. Okay, let's paste it into my right over here. These are two my executor, and I have different partition over here. Let's say I have one partition over here. Okay, and I have another partition as it's changed the color of that. So I have another partition like this of yellow color. And in executor 2, these are two different executors. So let me write it as executor 2. This is my executor 1. Okay. And this is a very, very easy topic, and you don't even need any practical demonstration for that. It is that easy, believe me. Just follow my instruction. So as you can see, I have four color combination, four representing the four different partition. Okay. Keep this in mind. Now what happened is, let's say I have a computer, and these were my executors. Okay, and I will definitely have my driver node. Okay, so let's say this is my driver node, which is very different from these two. Okay, these are my driver node. Okay, till now we know that for joining we need two data sets. Okay, then let's copy the two different data sets as well. Let me copy it from here. Okay, these are two my data sets. Two different data sets. Let me copy it here. Okay, I hope it is visible. I will make it a bit smaller. Okay, these are two of my data sets. Okay, and I will name it as data frame 1. I will name it as data frame 2. Okay, now what happened is Spark has a very best feature. It is able to decide which is the smaller table. Okay, and what happened is, let's suppose this is my huge table, and I have entry of let's say 7, then 8, then 10, and it was of size let's say 1 TB. Okay, and my other table which I want to join, it was of size around 1 GB. So what Spark will do, initially it goes for broadcast join itself. So what it is going to do is, it is going to take this smaller data set, that is my data frame. It is going to pick it and put it into my driver node, into my memory. So you will say, okay, Shubham, so what's the difference between the hash and this, right? There is a difference. It is not going to create hash. It is not even going to do the shuffle. That's the important thing. It is not doing anything. It is just taking that complete data set. This data set it has taken, right? This is my data set of 1 GB. It has taken this whole data set and it has kept into the memory. Now, what it is going to do is, this data frame 2, it can be present anywhere, right? Either in this, what we say, partition, either in this partition it will be present, right? Or it can be present in this partition as well. The portion can be present, right? The data frame partitioning, we all are knowing, right? And this data frame can also be present in Billow's data set. We need to join, basically. There are multiple partitions spread over the multiple executor and multiple nodes. You agree with this point? You will say how? So if you are not clear on this topic, you need to revisit my repartitioning and coalesce video, and you need to even revisit the partitioning video, the theoretical one. That's how where you will understand how this executor have different partition and how these partitions are created. So what it is going to do, it is going to broadcast this whole table, this whole 1 GB. It will give this to one executor 1 itself, and this will give this whole table to executor 2 itself. Okay, take it as a complete and do your work. That's it. Joining has been done. How the joining will be performed? It is very easy. Like, it will say df join is equal to df dot df underscore customer customer dot join. No hint, nothing. Just give df order order. These are two my data frames. And what is my key? My key is customer ID. Give the customer IDs customer customer ID. And how you want to do it? You want to do it inner, like inner join or even left join. You want to do, let's say, left join. But that this is just the formula, not I will say formula, the code. It will directly go and do the broadcast join for you in this case. That's it. This is the complete broadcast join. So, what is the meaning of this broadcast here? You are not going to shuffle the data, not here in the driver node, not in the partitions. Okay, you are not going to sort the data as well. That is the two expensive operations you have just eliminated. Now, what you are doing, you are taking this whole data set which is present in your RAM, in your driver node, and you are broadcasting it to executor 1, you are broadcasting it to executor 2. Let's suppose you are having 8 worker node and 8 worker node were having a different data, right? We talked about this was a 1 TB data. So let's say if you have created like partition, so there will be around how many partitions? 100? Partition for 1 TB, correct? Or 10 partition. So 1 GB partition, if you take 1 GB partition, this partition is belonging to 1 GB, this is 2 GB, this is 3 GB, and this is 4 GB. So basically 4 GB partition is present over here. Likewise, you will have 100 GB, 100 partitions, correct? So going to stream the data for you, broadcast the whole table, give it to single executor, and it will say perform your work. I don't care. I will not shuffle. I will not sort the data. So this is how our broadcast join is very different from hash join itself. We are not doing repartitioning. And how hash was different? We are not doing the shuffle. We are not doing the sorting. So this is how our 3 different partition work. And actually it has, the diagram is, I believe it is very visible to you guys. Okay, so the diagram lies it here. And I don't believe we need to do any practical demonstration for that. And by default, Spark usually go for broadcast join wherever possible because this is the fastest join and this is the interview question as well. So they will ask the difference between these 3 joins to you now. Okay, so our next video will be over this only, how these 3, what is the major difference between these 3 partition. And if you have watched my previous video, you might already have been known by now, like what is the major difference between them. So if you are not clear on this, head over to the next video for the difference of these 3 and you will be very clear on it. Okay. So thank you for watching the video. See you in the next one.